Well, first we start turning on the calculator, then we push the button menu and we go to graph. That is the number 5. Now we can see different situations there, but we're gonna choose J1. So we start putting the operation that is 0.5x3 minus 3.2x, and as you can see there we have the operation there with a correct order and in a simple way. After that we have to observe the coordinates of point A and point B, so we push X and we put F6, and now we can observe the graph. Well, we sketch the graph there and you can observe that. Now with the graph sketch we have to, well, as I said before, we put shift and then F5, that is GSolve, and here we can observe that we have max and min. First we push max, that is F2, and we can observe the coordinates of the maximum point, that is 1.46. Then we make the same operation, but now with the minimum is shift then F5 and we put minimum, and you can observe that y is equal to minus 3.11 and in maximum x is the same, 1.46. Okay, with that we finish the first step.
Well, after doing that, we go back to the main menu to look for the inflection point of F. We go back to run math. After that, we need to select shift and options. Then we select the letter F4 for looking for the derivative, that is dx. After that, we can look that we have the derivative. We select the function that is 0.5x to the 3 minus 3.2x. After that, we select that the x is equal to the number 0, and we have the answer that is 16/5. With the sketch that is to convert this, we have the minus 3.2. We go back to the number 5, that is the graph, and we select shift option F5 to the GSolve. With this, we'll look that we have our first function. We go back to shift F5 and we put the value of x, that is 2. With this, also we select x, and we can find that that x is equal to 2 and y is equal to minus 2.4. With this, we can look the maximum and the minimum of the inflection point.
Now, the final step, we have to write down the values of x for the negative rate of change, and we put the derivative of the function, that is 1.5 x2 minus 6, and we push x, and we can observe now the two graphs with the first derivative and the second derivative. But here I make a mistake, and we can observe the roots if we have the two derivatives and the two graphs. So what we do after looking of this was put exit and erase the first derivative. With this, we only have the graph of the second derivative, and with that we can observe the two negative rate of change, that in this case x is equal to 4 and y is equal to 0.